Hello again, class. This is lecture video number 2 for electric field. So in this video, I'll be talking more about electric field, uh, especially on how to calculate the electric field of a certain port charge at a certain distance away from it. Okay, so let me share my screen with you. I want to share the whiteboard there. Okay. So in the earlier video, is this the one that I did? Sorry. Sorry. Wait. This one. Mhm. Okay, whiteboard. There. Yeah, yun pala talaga. Bakit ganyan? Whiteboard zoom. Oh, meron pala. Whiteboard zoom. Sige. Ayaw niya eh. So we'll talk about, pangit na. Okay. Pardon the writing. So we will be talking about electric field of a point charge. Okay, later yung charge distribution. Okay. Hmm. Do we have different color here? I think I don't want this. No. Wait, pause. Okay. There. Okay. Ayan, this one. I want this one. Okay, so let's talk about the electric field of a point charge. In the earlier video, we mentioned that the electric field of a certain charge is the ratio of the force it receives divided by the magnitude of the charge. No? So in the earlier video, it has subscript not or zero because the charge that we use in the definition was a test charge. Okay? So, sige, lagay ko na lang din for a test charge. But in general terms, it doesn't have to be always a test charge. It can be any charge, no? So that in general, we can say that electric field as a vector, whatever is the direction of the force received by the charge divided by its charge. Whatever is the direction of F, that's also the direction of E. And then the unit is, of course, Newton per Coulomb. Okay. And it was also mentioned that the direction of the electric field is the direction of the electric force received by the positive test charge. So what do we mean by that? So say, for example, we have a positive test charge or any charge, for example, let's say it's positive Q. Yan. So if we use a test charge, a smaller test charge, if I place it somewhere here, the small test charge Q sub naught, okay, Coulomb's law will tell us that the force of interaction would be in this axis, no? Kasi diagonal ang imaginary line that connects the two. So if you have this imaginary line that connects the two, and this is a positive test charge, then the electric force, the force of the source charge on the test charge at this point would be repulsive. So this is F on the test charge. If I transfer my test charge somewhere here, okay, it's still, of course, a source test charge. This is now the imaginary line that connects the two. This is, again, repulsive force. So this is now the force received by test charge. We mentioned in the earlier video that the direction of the electric field of the source charge is the same with the electric force received by a positive test charge. So in that case, if at this point here, we know that the force on Q is in the second quadrant, then at this particular point, you also have here an electric field at that point. Pagdating ng test charge dito, the electric field of the source charge is in the same direction there. So that's the electric field. So if I'll put several places of my test charge in different places here, and somewhere here, so I know by Coulomb's law that this is the electrostatic force. At this point, connect mo siya. Then repulsive force. This is the electrostatic force received by your test charge because of the electric field of the source charge. Okay, take note of that ha, kasi nga it cannot interact with its own self, its own field. This is now electric force. So if we sketch now the electric field of the source, this is your source charge. Okay, and the smaller charge is a test charge. Yan. There's also the electric field. Then we say, ito na yung pinakita natin na you can see this in any physics book, no, pag nasa electric field discussion, that for a positive charge, point charge, a positive point charge, it's the electric field is directed radially in all directions. It's away from the source. Kaya, these arrows that I'm drawing, these are what we call the field lines. They are visual representations of where the electric field is directed. But in reality, you cannot see field lines because these are vectors that cannot be seen, but the effects can be seen and can be felt, no? So this is now the direction of the electric field. If I will draw concentric lines here with the source charge at the center, so I can extrapolate muna ha, kasi medyo malayo. So if I'll draw concentric circles with the test charge at the center, yan. So if I'll draw a circle like this closed surface here, and I'll sketch another circle with a larger, thank you for the automatic auto shape. Okay, if you look at the closeness of the field lines, no, these are called field lines, electric field lines. These are geometric figures that we use to visually represent electric field. In the first circle here, oops, ayan na naman siya, na may napindot na naman ako, ayan. So in the first circle here, you notice that the field lines are crowded. Okay, ayan. So crowded field lines would mean a stronger electric field. So the field here, field is stronger because you can see the density of the field lines is big. No, field is strong here, stronger than in the other field. Kasi you see several field lines in this certain closed surface and they are close with one another. But when we go to circle 2, the field lines now are medyo malayo na yung distance nila sa isa't isa compared here. So in the bigger sphere, with this radius, if we call this as circle 2 and this is circle 1, so this is R2. Yan. So the radius of sphere 2 is less than radius of R1. The field lines are farther from one another. So the farther the field lines are, it's like less field line in a certain volume here. So we have a less field density here. So in sphere 2, you'll have the magnitude of the electric field in sphere 2 is also less than the magnitude of the sphere, magnitude of the field in sphere 1. So we will see here the inverse relationship between electric field and R, and that we will determine now the exact relationship between the strength of the electric field and the distance between the point of evaluation and the source charge. Okay? So meaning, we will have another definition of electric field. Kasi itong F over Q, this is not talking about field strength at a certain distance from the source. It's just telling us of the force received per charge. No? So how do we determine now the relationship between electric field and R? Yan. But before that, let's show muna the direction of the electric field of a negative charge. So for a negative charge, okay, I'll use a blue color. So negative charge, this is negative Q. I will use another positive test charge in different positions. Kasi ite-test ko kung ano ang direction ng kung meron bang interaction, no? Tsaka anong direction ng force. Kasi kung ano ang direction ng force, okay, take note, for a negative charge, the direction of the electric field is opposite. This is very important, a very important concept. Is opposite to the direction of the force on it. Okay, I will box this because this is important. Pero pag positive siya, if it's a positive charge, kung sabi natin kanina, for a positive charge, so same statement, pero dito ko ilagay sa taas ha. For a positive charge, the direction of electric field is the same with the direction of the force on it. Okay, take note of that. So we will use this principle in determining the electric field direction of a negative charge. Okay, dito tayo. This is now the imaginary line. I'll draw the imaginary line that connects the source and the test charge. At this point, it's in the third quadrant. At this point, it's in the fourth quadrant. So this will have an attractive interaction. Tama ba? So here, si source charge will attract. Ayan. So ito yung force of interaction nila. Therefore, the force of, ay, baliktad ako. I'm sorry. Tama ba? Lagi. So in this case, this is the force, right? For a positive charge. So the electric field now, yan. So since this is, yun. So since our source here, baliktad pala. Ano ba? Tama nga. So our source here is a negative charge. It will exert this force here. So the electric field now would be in this direction. Am I making sense? Wait. I don't want to confuse you. Wait. Erase. Let's do it again. Wait. Oops. Wait lang na. Tubuhin ko muna kay murag na confusing ang akong gisulti. I want to determine the direction of the field. So, dapat pala I will use a negative charge. Tama man yun. I'm battling with myself. So, balik tayo. Negative, the direction is opposite to the direction of the force. Electric field is opposite to the direction. Pero dapat hindi siya mag-away. Wait. Wait. Okay, balik tayo. So we will focus on the principle, no? Yan. Tama pala yung kanina. Okay. So I have here a negative source charge. And then I will put still a positive test charge here. Positive test charge. Positive test charge. Another test charge here, positive. Okay. So the imaginary line that connects the two. Yan. Yan. Okay. We will anchor on the principle that the electric field is in the same direction with the force received by a positive test charge. We are using a positive test charge here. So the attraction here goes here. This is now the electric force. So if the electric force received by the positive test charge is inward here, then this is also the direction of the electric field. Yan. So same here. force of attraction, F, force of attraction, F. And since the recipient of this force is a positive charge, then there's this electric force, electric field also in this direction. So if you notice, if the source charge were negative, the electric field that it establishes around it is directed into it. Okay? Kaya, when you see any physics book on electric field, it will show a negative charge like that. And then the electric field is radially into the source. Ayan. So these are the electric field lines going into. Ayan. So for a negative charge, we can say that for a negative charge, its electric field is directed into it. Into it. Whereas if it were a positive charge, the electric field is away from it, radially, along the radius for a point charge ito. The electric field is there. Okay? Now you might ask, what about the statement there, ma'am, that for a negative test charge, the direction of E is opposite to the direction of the force? Ganito siya kung baliktarin natin. So say for example, if my source charge were positive, this is my source charge, big Q. Okay? And then if I place a negative test charge somewhere here, negative test charge like that. So this is the line that connects the two. So the interaction is attractive. Source charge, big Q, will attract test charge into it. So this is the F. But since the recipient of this force is a negative charge, then the direction of the electric field at this point is opposite to the direction of the electric force. So if the force is in this direction, the electric field will go 180 degrees off. This is now the electric field. So it's still consistent, di ba? If we put the negative test charge here, the electric force is going there. So the field is also 180 off. Yan. Let's put it in another place. This is negative. So you have this electric force by Coulomb's law, and then the electric field is going there. So if we put all the electric field lines here of our source charge Q, then it's still consistent that the electric field of a positive source charge is directed away from it. Yan. Kaya it's not violating what we showed earlier, no? Basta lang kay bantayan ninyo, if it's a positive source charge, the electric field is radially out in all directions, okay, along the radius. And if it's a negative charge, it's into. Okay? So ang titingnan ninyo, what is the sign of the recipient of the force? If the recipient of the force is a positive charge, then whatever is the direction of F, that's the direction of the electric field at the point where the charge is located. Okay? But if the recipient of the force were positive, like this, whatever is the direction of the force received by the positive recipient, that will also be the direction of the electric field of a source charge at that particular point. Okay? So itong maliit na test charge dito, it has its own electric field, but it's weaker compared to the electric field of the source charge. Okay? So pag nag-analyze tayo ng problems later, you have to determine which is the source and which is the test charge. What's important here is this. The source charge, the electric field of the source charge does not depend on the presence of a test charge. Okay? With or without a test charge in the vicinity of the source, there is still electric field there. Okay? And then it will depend nga on how far the point is from the source. Okay? So again, if we draw concentric circles here in our negative charge, you still notice that the field line density in the sphere that is closer to the source will be uh, denser than the density of the field line as you go farther. Kaya, galayo ba ang linya? Malayo ang distance na ito kumpara sa distance dito na malapit siya sa source. Okay? Ayan. How many minutes na ba ito? I think I have to stop here and then we will derive the dependence of electric field, the strength of the electric field on position in the next video so that it will not be very long. Ayan. So, ta-ta for now.